We are Team NEURANOVA. The problem statement ID for our problem is 25108. Problem statement title is Development of AI-powered FRA Atlas and WebGIS-based decision support system for integrated monitoring of Forest Rights Act. Implementation to be concentrated states is Madhya Pradesh, Tripura, Odisha, Telangana. Theme for our problem statement is miscellaneous. The problem statement category is software and our team ID is 83749. So we are Team NEURANOVA and our project is titled AI-powered FRA Atlas and WebGIS-based decision support system, which we proudly call Tribalitica, which stands for Roots of Tradition and Wings of Rights. The core idea behind Tribalitica is to build a centralized intelligent platform that digitizes, analyzes, and visualizes data related to Forest Rights Act. Our system focuses on ensuring transparency, improving decision making, and empowering tribal communities in states like Madhya Pradesh, Odisha, Tripura, and Telangana. The problem statement: the Forest Rights Act was introduced to recognize and the waste the forest rights of scheduled tribes and traditional forest dwellers. However, its implementation faces major challenges such as scattered and unverified records, lack of centralized digital data, manual monitoring and verification processes, and the absence of smart linkage between FRA beneficiaries and relevant government schemes. Because of these issues, large portions of forest dwellers still remain unaware of their rights or deprived of connected development schemes. Proposed solution for our problem: to overcome these challenges, we propose an AI driven GIS enabled platform that brings together all the data related to FRA claims and land rights into one unified system. Our solution integrates artificial intelligence, remote sensing, and WebGIS to create a comprehensive and data driven view of FRA implementation across multiple states. We aim to make the system capable of mapping FRA claims and granted titles through AI powered visualization using machine learning and satellite imagery for automatic asset detection like forests, farms, and water bodies, and enabling policymakers to track, verify, and plan interventions seamlessly. The MVP, that is the uniqueness and novelty of our problem statement, and the idea we have proposed is that our MVP consists of three key components: AI powered FRA Atlas, a dynamic interactive map that shows claims, title status, and village assets in real time; decision support system, an AI based recommendation engine that connects FRA title holders to government schemes like PM Kisan Jal Jeevan Mission and MG Narega based on eligibility and resource mapping; AI based asset mapping. This module uses satellite imagery, computer vision, and classification algorithms to detect and categorize land assets automatically, creating a complete resource atlas for each village. Together, these components will digitize unstructured powered FRA data, then generate AI based insights, and empower government bodies to make data driven policy decisions. Expected outcomes from our ideal solution is that with the successful implementation of Tribalitica, we can have all FRA related data will be digitalized and unified under one GIS based platform. Beneficiaries will be efficiently linked to suitable schemes, and authorities will gain a clear AI generated overview of assets and resource gaps at every administrative level. In short, the system ensures transparency, accountability, and inclusivity in the implementation of Forest Right Acts. Now I will explain our technical approach which forms the backbone of our project Tribalitica. Our solution follows a multi-layered modular architecture ensuring scalability, efficiency, and data security. Each layer has a distinct function, but all are interconnected to provide a seamless flow of data from collection to analysis and visualization. At the core, we begin with data source layer. This layer gathers information from multiple sources, government databases, existing FRA claim documents, satellite data, and community level inputs. All data collected here becomes the foundation for further analysis. Next, the pre-processing layer comes into play. This is where the system performs data cleaning, standardization, and feature engineering using Python-based ETL pipelines. Here, we ensure that all the datasets, whether structured or unstructured, are made consistent and reliable for machine learning. Once pre-processed, the data flows into AI and machine learning layer, which is brain of our system. We use frameworks like TensorFlow, PyTorch, and Scikit learn for predictive analytics, classification, and anomaly detection. For example, satellite imagery and geospatial data are analyzed using AI models to identify land types such as forests, agricultural areas, and homesteads. The next stage is decision support layer, which uses AI outputs to generate policy insights and scheme recommendations. This helps connect FRA beneficiaries to government programs like PM Kisan Jal Jeevan Mission and Mahatma Gandhi National Rural Employment Guarantee Act, while also helping authorities identify priority areas for development. Then the WebGIS integration layer visualizes all the information on an interactive digital map using tools like Leaflet, Mapbox, and PostGIS. We enable users to view FRA claims, grant titles, and village level resources in real time. This allows for better planning, verification, and monitoring by officials. The engagement layer provides the front-end interface for different users, including administrators, field officers, and local communities. It includes web dashboards, mobile apps, and analytical tools that are intuitive and easy to use. Finally, surrounding all these layers is security layer, which ensures that the system remains trustworthy and tamper-proof. Use blockchain, JWT authentication, and role-based access control to protect user data, verify document authorities, and maintains transparency across departments. For our technological stack, the front end is built reacting using React.js, HTML5, CSS3, and Flutter. The backend uses Python, Flask, FastAPI, Node.js, and Express. The database combines PostgreSQL and PostGIS for geospatial data handling. Cloud deployment is done using AWS, Docker, and OpenStack for scalability. For data visualization, we use Power BI, Tableau, Streamlit, and Leaflet. In short, our technical approach ensures that Trabelistica is robust, modular, and future-ready, capable of handling large-scale data, supporting AI-driven insights, and integrating seamlessly with government systems. This makes it strong, scalable, and practical solution for real-world implementation. Now moving to the feasibility and viability of our solution, Tribalitica. Our project is designed to be both technically feasible and economically viable, ensuring that it can be implemented, maintained, and scaled across multiple states with minimal friction. Let's start the technical feasibility. All the technologies we have used, like Python, Flask, TensorFlow, PostGIS, and React.js, are open source and widely adopted. This reduces dependency on proprietary tools and ensures easy integration with existing government systems. Our architecture is modular and cloud based, which means each layer, data collection, AI processing, and visualization can function independently and be updated without affecting the others. This modular design makes deployment across various departments and states both scalable and cost effective. Next, the economical feasibility. Since most components are built on open source and frameworks, the development and maintenance costs are minimal. Additionally, our use of cloud deployment reduces the need for heavy local infrastructure. We also aim for long term cost savings by reducing manual paperwork, claim verification delays, and redundant field visits, saving both time and government resources. On the operational side, the system can be easily managed by existing department staff after short training sessions. The dashboards and mobile apps are designed with simple, intuitive interfaces to ensure even non technical users can operate them effectively. From a viability perspective, Tribalitica aligns strongly with India's Digital India Smart Governance and Forest Rights Act objectives. It has clear potential for national level integration as the same architecture can be replicated for other social welfare and land management schemes. Finally, the project ensures social viability by directly empowering tribal communities, providing transparency, accountability, and accessibility to welfare benefits. So, in summary, our project is not just a technological advance but also practically implementable, economically sustainable, and socially impactful, making it both feasible and highly viable in the real world.
Our project Tribalitica will create a huge positive impact for different government bodies and communities. For the Ministry of Tribal Affairs, it helps in real time monitoring of FRA progress and support better policy making through accurate data. For the State Tribal Welfare Department, it simplifies the process of claim verification and scheme allocation using everything faster and more transparent. The Forest and Revenue Department can use our system for accurate mapping of forest and land resources, which improves forest management and planning. Planning and development authorities can use the data for proper infrastructure and agricultural planning in tribal areas. NGOs will get verified and organized data to plan community engagement and welfare activities more effectively. Then, our solution also provides many key benefits. It offers centralized FRA records where all claim details are digitized and standardized for every state in one place. Through the state level FRA Atlas, user can view interactive maps showing claims, titles, and village boundaries for easy understanding. Using AI based resource mapping, the system accurately detects forest areas, farms, and water bodies, helping in better decision making. An AI integrated decision support system connects all FRA related data directly with government ministries for smooth coordination and monitoring. Then, real time monitoring and feedback. uses the cloud and mobile dashboards, also allows authorities to track live updates, get feedback, and ensure continuous progress across all states. This is all about impact and benefits of tribal Tika.
Moving on to our final slide, research and references. Our work on the Forest Rights Acts or FRA 2006 is based on official data and credible government sources. The main reference is the Forest Rights Act 2006 and the guidelines provided by the Ministry of Tribal Affairs, which include detailed reports on claims, patas, and community forest rights. We also refer to data from state tribal welfare departments of states like Madhya Pradesh, Odisha, Tripura, and Telangana for ground level information on FRA implementation. For mapping and spatial analysis, we utilized satellite and remote sensing data from sources such as Sentinel-2, Landsat 8, and Google Earth Engine. Additionally, government schemes data like PM Kisan, Jal Jeevan Mission, and MGNREGA were studied to explore how FRA beneficiaries can be linked to existing welfare programs. Finally, several academic and government reports were reviewed to understand implementation challenges, especially related to GIS and legacy record issues. These references together helped us build a strong and data driven foundation for our solution. Thank you.